Hi Jakub, how you doing?
Hello, thank you. I'm doing very well actually.
It's great having you here, and thank you in advance. Before we will start, I would like you to introduce yourself and tell a little bit about you, what you do, etc.
Okay, I'm very happy you have not asked me who I am because that's actually a super hard question, and I'm taking a year off to try to answer that. But I guess in this context, I can just focus to the much simpler question: who I am as a programmer. Yep, I'm from Czech Republic originally. I've been living in Norway for the last 14 years. The last few years I've been working in RDoC, which is a Norwegian software as a service scale up, working in Clojure, which I enjoy a lot. And yeah, I've been in love with Clojure for some, I don't know, 10, 14 years. I like to write, so I have a blog where I write about technology and my experiences with it, or I used to write before my year off. And yeah, I'm very fond of not feeling pain. So that's how I came from Java to Clojure and from waterfall to more agile and lean development. And that also informs my interest in technologies such as Fulcro and Rama and Wolfram, which we will certainly talk about.
We will speak a lot about that. Before we will start speaking about software development, so after 14 years living in Norway, do you already in Norwegian or not yet?
Yeah, I do. I've been lucky enough to work in some companies that use Norwegian as main language. So it's not as well. I wanted to say as good, but maybe that's wrong expression. It's worse than my English, but it's quite good.
Is it like if somebody knows German, for example, is Norwegian learnable or is it its own thing that's very difficult?
I claim that for me it was the easiest non-Slavic language to learn since I knew English and some German. And
Yep.
I had a German friend who learned Swedish, which is very similar in essentially 2-3 months.
Mhm.
So yeah, it helps a lot. It's
Awesome.
much
Awesome.
much simpler than Finnish.
Yeah. Before we will start speaking about Wolfram, Wolframite, and so on, so you were working on other things in the past. One of them is Fulcro. What pulls you to work on open source?
Yeah, I guess my two main motivations is I want to give back to community because I get so much in the form of both open source and help, uh, and also typically I find some tool that I want to use and there is some gap to fill, right? So with Fulcro, I started a Fulcro community and made a lot of resources for people that are new to Fulcro and want to learn it. So to kind of smooth the path for them, I'm very passionate about that and the possibility that Fulcro has to make people's lives simpler and
Yeah.
better. And that's similar with Wolframite.
Yes.
Kind of, I discovered Wolfram. We can dig into that more later, but essentially, yeah, I saw that that was something that should be done, and I was in the place to help there. So that's it.
Yes. Yes. It's super useful because actually Clojure is a great language to be used in, let's say, academic or research and development field, and it's not used that much. And Mathematica, like a platform, Wolfram as a language and engine, has a lot to offer, right? Um, so
Yeah,
you
sorry, I guess I could give some context for Wolfram to possible listeners who have not encountered it before. So if you want the full context, you can go watch my and Thomas's Clojure work that we talk that we did a month ago. So Wolfram language is what powers Mathematica, which is super popular software used by many scientists for scientific computation, and it can do a lot of stuff.
Yep.
And library that me and Thomas work on, we have not made it. We just took it over and make it more accessible, hopefully. Wolframite tries to make a bridge between Clojure and Wolfram to be able to not the language, but the Wolfram engine that actually does the computation.
Yes.
And offload some part of work to it.
Now, when you mention Wolfram, not the language, but the engine. So there are 4 different things. There is Wolfram engine, Wolfram language, Wolfram cloud. There is Mathematica. Would you mind to explain what is what and what?
I can try. So I think that originally there was only Mathematica, so the desktop tool that scientists use to do their calculations and simulations and whatnot. Later, the language used inside Mathematica became more independent, and that's the Wolfram language. And since a few years ago, there is also a thing called Wolfram engine, which is binary thing you can download, and there's the computational core that you can connect to via API or some CLI thing and send it Wolfram expressions and get back answers.
Yes.
And Wolfram Cloud is part of the offering that Wolfram makes. It has many things. You can have online notebooks, and you can make interactive web applications to connect to your computations and whatever. But from our point of view, what's important is that it's some kind of computational cluster that has extra power and extra capabilities that Wolfram engine sometimes leverages for things it cannot do itself.
Yes, like large language models, for example.
Yes.
Yes. So you can use Mathematica as IDE. What you write is running on Wolfram engine. The code is written in Wolfram language. And if Wolfram engine cannot do the thing itself, it offloads to Wolfram cloud. Am I right?
Yes.
Yes. And Wolfram engine is for free. Anybody can download it, right?
Yes, you need license, but you get license for free. And there are some conditions. You cannot use it for production applications, essentially, right? You can do it for your own experiments, whether that's home, at work, at school. So you even at work you can use it, but as soon as you want to turn it into product, you have to get proper license.
Yes, yes. And now in this like Wolfram language, Wolfram engine, and so on, there is Wolframite and what exactly is Wolframite doing with this Wolfram ecosystem?
Yep. So it is a library that enables you to write Wolfram expressions in essentially as Eden, as Clojure data, and we then translate that into whatever format Wolfram actually needs. We send that over to a Wolfram kernel, which we are running as a separate process. It does the computations and returns the results to us, whether it's just data or some graphics. And then we translate that again into Clojure data if it's data, so that you can easily consume it from your.
And how is the communication happening? Like what format or and the way how you communicate?
There are 2 ways to talk to Wolfram from the outside: the older C API and the newer Java API, which is reportedly better according to Wolfram people themselves. So we essentially use the Java API to both construct something called JLink expression from the data and to send it over.
Yes, yes. So this is how you communicate. And overall, what's the architecture of Wolframite?
Yeah, I guess I actually described it already. So you start by starting Wolframite, which underneath starts the Wolfram engine process.
Yep.
Then you write your Wolfram code as Clojure data. So it looks very much like Clojure code, only it's not evaluated, but it's sent more or less as is to Wolfram. Right. So we have this translation phase where it translated, then we send it over to evaluate, get back, and translate again for you.
So you have a map of Clojure symbols and Wolfram symbols, mapping between those two, and in some step you take a tree of S expressions and you transform them into Wolfram like proprietary format. And then when you get
Yes.
a response, you do the same thing, but the other way.
Yeah, you could say that.
Okay. Wolfram engine is stateful, right?
Yes.
So you can create data in Wolfram engine and evaluate them.
Yes, that's quite essential to being able to actually work effectively with it. So if you have some large data that maybe you actually don't want to load on Clojure side and then send the raw data over, but you want to load them on Wolfram side, so you load them into some Wolfram side variable, right, and then keep it there. I just realized that maybe for the listeners, it might be also interesting to dig a little more into the context of why is Wolframite actually useful and interesting.
Yes.
Should we do it now or later?
Yes, please. Yeah, the motivation is very important.
Okay, so I actually I can take even one step back and see how I got into Wolfram. So as mentioned, I'm kind of driven by pain avoidance, and when I discovered Wolfram and what it is capable to do in just a few lines of code, I was very amazed. It's really great. Yeah, language doesn't really describe it, right? Because it's much more than language. It's a computational platform. One of the big distinguishing features of it is that it has built-in knowledge base, and it has the ambition to make all human data computable, so program accessible. So this knowledge base, it has information about everything, different chemicals, compounds, about nutritional facts, about geography, like what is Europe, what are the countries there, their capitals, their locations, how many people they have. So it's like Wikipedia inside programming language, but tuned for actually programmatic usage. And so that's one key aspect of Wolfram. And other key aspect is that it has very high level functions. It has some, I don't know, few thousand functions, and they kind of, why in normal programming languages, you as a programmer have to do a lot of work to process the inputs and give the function exactly what it needs. Here, Wolfram tries to do as much for you as possible, because originally it was not made for programmers, it was made for scientists who wanted to get job done, right? So it has, for example, the import function. There's a single import function in Wolfram, and it can import any kind of data that Wolfram works with. And it's really smart about, like, it looks at what is it, what it most likely this data is, how should I parse it, and so on. And all the things in Wolfram can be combined together, so you can make an array of images and make a function of them, and
one of the for people who never used Mathematica or Wolfram, I would say one of the wow factors is really how smart it is about what it can do with the data. Really, if it knows that it's a video, it's a picture, it's a map, it's a set of locations, it automatically can do plenty of things just based on this knowledge, and the functions are always trying to also return as clever output or as clever meta information about the output as possible. So this allows, for example, perfect visualizations, and I don't think there is any other platform that has this. Even like Clojure would be absolutely ideal language for such a thing, but I think Wolfram is kind of unique in the whole like programming world. So so when you write a code in Clojure, you send it to Wolfram engine, and then you get that clever output, which might be, for example, a map or a video.
Sorry, I would stop you there. I would continue a little more with the context setting.
Yes.
So I described why I find Wolfram amazing.
Yes.
And 2 years ago, Stephen Wolfram, the author of Mathematica and Language, had a talk at the Clojure conference. And he was actually interested in better interoperability with Clojure. When you look at Wolfram, it's kind of Lisp as well, so it's very close. Actually, it might be more than 2 years. Anyway, some time ago. And then a little later, 2 years ago at Clojure Conch, my fellow Wolframite maintainer, Thomas, and Daniel of Cycloge had a really great talk about the Cycloge community and essentially about the need for better tools and better pipelines, because what actually scientists such as Thomas want to do is they want to get their data from their sensors and process them and essentially at the end turn that into paper. Right? Currently, people mostly use Python for that as the glue because that is what is available. But Clojure has some great advantages over Python, and it would be awesome to be able to use it. But currently, there are some gaps. Like the Cycloge community has done an amazing job at filling those gaps, and there are much fewer today than they were before. But still, there are some. Plus, Wolfram is the best in class for some kind of problems. So what we wanted to do, inspired by Stephen Wolfram and this talk, me and Thomas, is to essentially bring Wolfram to the Cycloge masses so that they can use it both to plug in these gaps, because whatever scientific computation or data processing, whatever you might need to do, Wolfram can do it, and also to offer it as a tool for those who know that it's the best tool for their job. Right, so that's why we do this work. I didn't really want to work on Wolframite, but I see that as very important for the Cycloge community and for my friend Thomas. So that's the context why Wolframite is important. So it's essentially both for people in the Clojure and Cycloge community to be able to do more of the processing they want to, but also to kind of get into academia and to give scientists better tool than they currently have as an alternative to the Python-based tooling. Sorry, I cannot hear you. I'm not sure what happened there.
So what are some cool things that Mathematica or Wolfram can do and are very difficult in Clojure?
I would highlight two things. One of them is symbolic computation. Typical example is when you have some complex equation and you want to simplify it. So there is some work, Richie has done some amazing work on that, but Mathematica has some decades of work in it. And it has been designed from start to be able to do these kind of things. So it's just the best of class, according to my personal scientists.
Yes.
And the other thing, which is super about Wolfram is, as I already mentioned, is that it has these high-level functions that require very little from you. In Clojure, you can write really efficient code that does things quickly and resource sensitively. But when you are a scientist, that's not the problem you are dealing with, right? You want to explore ideas, you want to experiment quickly. You don't want to spend half a day learning how to import some weird format into your program so that you can work on it. So it has these very high-level functions that also combine very easily together. Plus, it has been used for scientific computation for decades. So there is a lot of existing body of knowledge and existing functions to do even very niche things.
Yes.
Right? So it's awesome prototyping and exploration tool.
Yes. So things like optimizations, solving equations, working on maps, and so on, are some things that Mathematica can do, and in Clojure it would take a lot, right? You were showing an example on Clojure. Was it something like using machine learning to recognize objects in videos? And I forgot what was the thing.
I had two examples. They are both somewhat visual, but I can try to summarize them. So the first one is about having a video with a dog running, and I detect the dog there in each frame and highlight it in the video. And this is essentially 3 lines of code of Wolfram, right? And the first line of that code is importing the video as a list of images, right? And then essentially I map image recognition function, or rather object recognition function, over those images, giving it as input the entity of a dog that's touching on the built-in knowledge base. It knows what a dog is, and it obviously knows how to recognize one in video. And finally, I just export the video, and this time I map over it another function which combines the detected dog's information with the original frames to highlight it.
Yes.
I don't know how much code it would take in anything else, but I guess I would need to learn a bunch of libraries and write a lot of code to make them exchange data in the correct place. And
Yes. There is probably a massive data set of objects Wolfram engine can already recognize. So it will have flowers, trees, people, like day-to-day objects. So I guess for those use cases, it might be super simple, like 3 lines of code, while in any other language it would be maybe hundreds. It depends.
And I imagine you might be less lucky, right? You might want to recognize something that the built-in models don't recognize yet. But then it has, again, high-level functions for learning to recognize the thing and working with it. So it would be more likely more than 3 lines of code if you have something other than
Yes.
that's supported out of the box. But still, it would be far fewer lines than in other things.
Yes. But so now when you are building a technology that bridges Clojure and Wolfram engine, Clojure has its advantages and Wolfram has its advantages. So what are the advantages of Clojure over Wolfram language, Wolfram engine?
Yep. So I will shamelessly steal from Thomas's part of the talk we had at the Clojure. There are a couple of benefits we can see on the Clojure side. One of them, of course, is that with Clojure, we can also tap into Clojure libraries and the vast ecosystem of Java libraries. And that means also integrations with essentially anything. Wolfram is very smart and good at a number of things, but it's not always super fast. So it might be beneficial for you to, for example, get and pre-process your data using the Clojure Java libraries.
Yes.
And also to just connect to things and get the data in, for example, from your sensors or whatever. Right? So integration and data pre-processing is one aspect that might be better. Another one is that kind of Wolfram was born out of Mathematica, which is kind of notebooking solution, right? It was not created for writing programs. So it doesn't, for example, have proper namespacing. Everything is in the global context, and code reuse and code control in the sense of versioning is much more cumbersome, if possible.
Yes. Yes.
Yes.
Is the difference in performance massive? Like, is Clojure so much faster?
I tried to import some 400,000 lines of a CSV with some bike trips, and in Clojure it took I don't know 1-2 seconds, while in Wolfram it took a long time. But that's the price also you pay for the smartness, right? Because it tries to look at the data, all of the data, to figure out what type it actually is. Is this a number? Is this double, or is it just integer, and so on? So there's a lot of extra processing that might not be necessary.
Yes.
You can drop a level down, and then it performs better, but you also have to do more work yourself. Right?
And you lose.
I don't know the general performance comparison, but my general impression is that Wolfram is not super fast, and you don't want to use it on very big data sets and so on. But then it's really smart at what it does, so it's cost benefit.
Isn't it that Wolfram Cloud allows you to parallelize certain computations, so potentially huge data sets and bigger problems could be offloaded to clusters?
Yes, I believe so.
Yeah, but it will be more expensive. If you can do it in Clojure, it will be much cheaper, right?
Yeah.
And so this is, let's say, advantages of Clojure all over Wolfram language and Wolfram engine. Now, what are advantages of Wolfram ecosystem over Clojure ecosystem and Clojure?
Well, that's what I've already mentioned, that you have this amazing computational engine that can do essentially anything as you might want to do as a scientist or somebody working with data or geography or video or images or large language models or many other domains. So it is a huge repertoire of functions, and it has these very high-level functions, right? Plus, it has this built-in knowledge base that you can combine with your data. So it's very unique value proposition, I would say.
Yeah. So speaking of those high-level functions, so people might not like understand what it means, because like we call it high-level functions, but how clever is Clojure with those, like depending on what data you send to this high-level function, what happens? How is it different from other languages?
Yeah, well, if we take very simple example of plus, right? So in Wolfram, you can obviously plus numbers, but also vectors or matrices,
Yes.
and possibly other things as well. While in most languages, you would need to use dedicated functions for those things. But when I say high-level function, I mean, for example, okay, I take sequence of locations, and I just have a function that detects the shortest path through them, which is, I believe, NP complete problem. So it has to do some smart heuristics. And we have this import function, which you just give it a file and it imports that. It discovers itself what format it is in, what is the most convenient way to do that. Of course, it takes tons of options, so you can actually influence it if you want to, but it can do a lot of work for you. It has also some in the domain of machine learning algorithms that
Yes.
can kind of these machine learning algorithms often they have a lot of parameters that you can tune. And some of those in Wolfram they can tune them themselves, right?
Yeah.
It takes time, but they do it for you.
Yes. Another thing is a knowledge base, which is probably another massive advantage. What is it about? What does it contain?
Yeah, so as I was saying, it's the image I have in my head is just all of Wikipedia, but turned into computable form, and it's not just information, but it's also like raw data about statistics data from different domains and so on.
Yeah, so it's economic data, geographic
So
data.
it's anything from chemistry to science to language and social sciences and history possibly as well.
So there are most likely like gigabytes of data, and they are updated frequently. Yes.
One goal that Stephen Wolfram set for the Wolfram language is essentially to make the whole world computable, right? So make all human knowledge accessible from Wolfram. Of course, we are not there yet, but they work on making more and more information available.
This was a massive promise of semantic web that never realized, right? So you have this knowledge available now. Is knowledge in Wolfram and in cloud? So when you call Wolfram engine from Wolframite, do you need to do a request to the server or local?
Sometimes, most of the time, you just talk to Wolfram engine. But I noticed that some requests or some functions fail when you are offline. So obviously, some parts of it are require connection to the extended part of the knowledge base. I don't know exactly where the border between those goes. I know for sure that also some functionality requires actually the cloud. For example, all of the large language models, which even not only requires the cloud, but also a separate subscription, which I guess makes sense because it's expensive to run these things.
Yes. Okay, so yeah, by connecting this, you really enable scientists, both in social sciences and in STEM field, to really tap into all this knowledge and still use Clojure. At the same time, we were speaking before that there are certain limitations in the visualization of those outcomes. What is it about, and how can actually people help you with that? If there is anything people can do to help Wolframite.
Thank you. That's a great question. So as mentioned, so Mathematica originally is kind of notebooking thing, right? So it has very good visualization, and it can give you even interactive charts where you can track some parameters and see how the curve is changing and stuff. We don't have that yet. We can either get data back, or we can ask Wolfram to give us back image, right? Or we can use this Java thing that can take expression and then evaluate it, but still you end up with static image.
Okay.
What we would like to explore in the future, and we very much welcome help from people interested in getting this thing in place, is both to also be able to make more interactive visualizations, and also perhaps possibly get the data from Wolfram as data and then use Vega Lite or something similar to display it. There already have been some work on that, but we haven't had time to integrate it more.
I would say this interactivity is one of the massive advantages of Mathematica. Importing this to Clojure would be a big task with potentially massive impact for scientific community.
back to your question, how people can help us. So
Yeah.
of course, any code contribution is awesome, but also just go out and try Wolframite and tell us what works, what should be improved, and just tell people about it and maybe help them get started.
What libraries Wolframite relies on, and are there any libraries that are missing that would help you?
No, I don't think there's. I could point to some libraries. Well, if there was something that could take data from Wolfram and render that in the chart, that would be helpful. I think there was some JavaScript library exploring that. There might be something, but we don't have any clear need for some library that would make our lives awesome. And for the libraries that we use, it's not really much. Essentially,
Mhm.
we use essentially only Wolfram. We use a little bit of Clojure kindly because all our documentation is rendered in the Clojure notebooking
Yes.
solution, and we use Babashka file system library, and essentially that's it.
Okay. Okay. Um, so so besides working with RDoc, working on Wolframite, what else do you do? Or um, I know that you have been trying Rama. I haven't tried it yet. I should. How is the experience, and what is it about?
Yeah, I find drama absolutely fascinating. So for those people who have not heard about it, it's uh, mm, essentially programming platform. What it tries to give you is all-in-one solution for writing your backends from so with Rama, you get a cluster that you can and tools to deploy to it and monitor. And what the cluster does, it combines computation and storage distributed over a number of nodes. In a way, it could also be seen as a programmable database.
Mhm.
Right? That's meant by the storage, but here the storage and computation are intimately tied together so that you can optimize on which node the data is placed, make sure the computation runs on the same node. And what is perhaps the most important part about it is that in essentially all databases, you are given data model that you have to adhere to, while in Rama, you are free to make any model or any number of models. So essentially, you can describe the structure of the indices as data. So I want to have a list of things, or I want to have key value map, or I want to have this really nested thing with sets and stuff. And then it does it really efficiently. So you can structure your data exactly in the way you want to make your queries fast. And if you look at how the process of it, right? So at the entrance of the system, you have essentially something like Kafka, right? The thing that is append only, where you add your data. And on
Mhm.
that, you have connected ETL processes that turn that data into the indices that you then use to answer queries. You can decide which data you want to pre-compute, which parts of the computations you want to run at query time. So yeah, if it's one more part that you get from Wolfram is that it gives from Rama is that it gives you a new language, which is kind of superset of Clojure, and is made for being able to run distributed programs in very simple way, like taking the hard work of doing distributed
So
systems out of
it
it.
it sounds a lot like so you define those data structures, and when you ingest data, there are some workers who create something like materialized views,
Yes.
So you get data in the shape that's useful for you.
Yep.
And then on top of that, you build a layer that is like API for the front end.
Yes.
And it's written in Clojure or the subset of Clojure?
Superset of Clojure.
Superset of Clojure. And this can be distributed. And this is where Rama ends, or do Rama also solves the front end?
That's where they end. They have API for querying for data, and they can also actually push data. Thanks to the way it's written, it's very easy to know what data has changed, so they can kind of stream updates to the front end, but they don't deal with the front end at all. That's
Yeah.
their job. So there
And
is, I think, for example, demonstration of using Rama as the backend and storage with electric Clojure as the front end.
and is there like it? So it's the pattern is command query segregation. So either send commands or queries, or you can mix them together,
Yeah, no, they are separate. Yes.
separated. And do they have a solution for transactions or need some data and then you update them, then you read or update again?
Yes. So essentially, it is a distributed system, right? And when your code runs on a node, it has yeah. Now I can't remember the right word. Unique access to the, or yeah, nobody else can access the data at the same time, right? So you have transaction at that level. It's one thing that you or learning Rama. There is a steep learning curve because it comes with new concepts, and you have to think about things you did not think about before. But you of course get also all the benefits from that. And one of those things is sharding of data, like which data goes to not exactly which node, because you can change the number of nodes, but how is the data sharded, right?
Yes.
And then all data that is on a single node, then you can access it without being afraid of somebody else touching it. And they have also a solution for beyond a single node case. So yeah, there is very strong transactional support.
Yes. By clever sharding, if the data is not too big, you can ensure atomicity and keep it on one node so it's fast, right?
Yes.
If it's across multiple nodes, it might be slow, but still it's atomic.
Yeah, I wouldn't say it's slow. I don't remember enough details to really give any authoritative information. But essentially, yeah, if you have to be aware where your data is located and use the proper tools, and then it will be both fast and transactional.
Yes. So based on the how networks work, so when it's in one machine, you can get easily sub-millisecond transactions. In a network settings, you can go into tens of milliseconds, right?
Yes.
What are ideal use cases where you would use Rama?
Well, the thing I think that inspired it was Twitter, because the author Nathan, he worked at Twitter, and they have really awesome early article which introduces their kind of rewrite of some key parts of Twitter using Rama and using the Mastodon protocol as the communication layer.
Mm-hmm.
But I would say it would be any kind of backend system, essentially. Right? I have a tiny ERP system I made for a friend, which currently is running on a single node with Fly.io and Datomic, and I would like to replace that with the free version of Rama, which I think it has 2 or 3 nodes.
Mm-hmm.
So it doesn't need to be a huge scale art. If you have a huge scale, then of course you save much more, because the bigger the scale, the more the fact that it's a distributed system costs you. But
Yes.
even at tiny scale, you benefit from the ability to be able to use a single database with a very flexible data model. Right?
Yes.
You
Yes.
don't have to adjust your code to the data model of database and to constantly fight it as I do daily at work with Postgres.
That's Rama
I
have.
don't need to write like 3 databases to fill all my needs. I have a single database and I have the data exactly in the format I want for the queries I have to serve.
What happens when you want to change the shape of the data?
They have actually something called instantaneous migrations. So from your point of view, it is as if the migration happened at once, but of course, there's a tiny piece of code that translates the data from one format to the other one when you look at the data, while underneath they migrate on the disk. So it's made by essentially enterprise people for enterprise people, right? So it makes these things very convenient, and of course they know that data formats and needs will change.
It's super clever. You like migration is a function. You can compose functions, and when you read, you take all the unapplied migrations, you return it, and you replace the old data with the new data, and you know that you have already applied the migration. This is very interesting. So
Even if you should never use Rama, I think it's very interesting to go and read about it, and also just read the blog articles they have that both introduce Rama and also introduce some case studies where they help some customer to migrate to Rama. It's very insightful.
yes. So do you feel significantly more productive with Rama?
Well, not me, not yet. So I don't see it from the happy shore, right? I haven't crossed the ocean yet, but I see it from this painful shore. I see all the problems I have to solve daily because of the impedance mismatch between my program and my database, and I can imagine how much better my life would be if I did not have those impedance mismatches.
Yes. Even when you use Datomic, which is quite close to Clojure, still there is a mismatch, and you still have to transform the data or adjust your workflow to Datomic.
Yeah, it's in this regard, it's much better than Postgres, which we use at work, because the Datomic data model is much more flexible.
Yep.
But still, it's one fixed data model, and if you want to have, as you said, kind of materialized view optimized for a certain query, you can't really do that, right? Unless you maintain it in the program.
Yes. How does querying the database in Rama look like?
So you essentially submit this distributed query, and you use the same language for both writing the ETL processes that make the materialized views and for querying them.
Mm-hmm.
So you submit this query which you write in your programming language. So there's not a special database query language. It's essentially code.
Yes. And then, so it's all based on that you first model those materialized views, and then you take data from one view at one moment. Like you don't join in Rama.
You can join between them.
Mm-hmm.
And typically, to answer any complex queries, you will need to be jumping between nodes. Like, okay, give me data of those customers that are here, and then let's move to where the company data is. So yeah, you do combine data together.
Join. Okay. So you don't have to create a materialized view for each query.
Not for each query, no.
Or for each type.
You create the materialized views or indices to make your queries internal quicker, and then you can combine them together.
Yes.
right? So you typically you have multiple views of the same data. Like if you have users, so you most certainly would have an index from user ID to the user details, but then you might have a different index which goes from user ID to a set of IDs of other users that are somehow related to this user.
Yes, yes. And then once you create, let's say those, like you join some data, you might have a business logic. How exactly is the front end taking or like communicating with this backend, with this node you wrote? Is it REST API or?
I guess that's up to you, right? What Rama cares about is the backend itself. How you connect the front end to it, that's up to you. If you use REST or if you use something like full core with platform running on the backend, that's
So
decision.
I thought that you store those functions within Rama. Like it gives you the database and it gives you also the store for your backend logic.
Yes.
And somehow it exposes it. So, but you have to make your own backend server as well.
You have to make your own API layer, yes, to expose those things.
Mm-hmm.
So
Oh,
if you want to make a tiny Ring application that exposes REST API and then underneath calls the Rama code to answer those queries.
okay, okay. Super interesting. I wonder how Rama will succeed.
Yeah, me too.
There, like from the presentation or Clojure, it seems to me Nathan Mars have spent an insane amount of time thinking about what happens between the database and backend. Similar thing Dustin gets between what happens between backend and frontend.
Yeah, true.
So maybe one day they will create a super framework. But it seems to me that they are thinking, even when both of them think very hard, they think in different spaces, in different universes.
Yeah. It's good that you mentioned them. I would very much encourage users to go and check the Clojure talks. There were about 8 of them, and the vast majority was really amazing.
Yes, both of them were great presentations. When I mentioned Dustin Gates, like all the things, all the arguments why I would think that electric couldn't work, he actually answered all the things, all the ways how he solves that.
Yeah.
So, yes, he is thinking about it super hard. It was a great talk.
I was very skeptical of electric culture because it sounded too good to be true and too magical. But then when I digged into his writing and stuff, it sounded to seem to he really knows what he talks about, and he had many iterations working on the problem, and
Yes,
the solution seems to be really making good sense. I'm
yes,
also looking forward to see where electric culture gets.
yes, yes. Likewise. All right, let me ask you the last question. So, how can people support you?
The best support people can give me is to support Wolframite by trying it out, talking about it with other people, and perhaps even contributing code or at least issues.
Perfect. All right. Thank you very much. I hope we will get a chance to speak again in the future.
Yep, absolutely. It was a great pleasure talking to you. Thank you.